Hey, second video to our solving special systems lesson. Again, you don't necessarily need to watch this if you managed or if you went through the Desmos lesson for balancing systems of equations. I think it's called Balancing Act. Can't quite remember. Either way, if you've been through that, you don't necessarily need this video. However, if you still needed this video after going through that, you're in the right place. Nice job. All right, so solving special systems. This is another type of system that we will potentially be looking at, or that we are going to be we are looking at it right now. And again, we are going to do the same thing. We are going to solve this system just like we did in the last video. And as we solve this system, can use it any sort of method that we want to do it. We are going to figure out how many solutions this thing has. We found in the last video that we had a system with no solutions. So let's see what this one has. Here we go. If we look at this one, we have y equals 2x plus 1, and then we have 2x minus y equals 1, or plus 1 equals 0. I am going to set this up as an elimination problem because the last one was a substitution problem. Let's do an elimination problem. That means I need to get this second equation in the same format as the first. Okay, so it looks like I need y on one side, x and constant on the other. So I am going to subtract 2x from both sides. I get negative y is plus 1 is equal to negative 2x. I'm going to subtract 1. I get negative y is equal to negative 2x minus 1. So now I can look at both of them because I have y's in the same place, x's in the same place, 1's in the same way, or constants in the same place. Y equals 2x plus 1 versus negative y equals negative 2x minus 1. And if I combine these, or if I eliminate something, then let's see what happens and what do I get in the meantime? Or what do I get if these two equations are combined? So y plus a negative y equals 0 y's. 2x plus a negative 2x is 0 x's. Unhelpful. 1 plus a negative 1 equals 0. Essentially, I have eliminated everything. Did I make a mistake? No. It's going to feel like you make a mistake when you're dealing with these problems in this unit or in this lesson, mainly because either you're going to get a solution or your solution is going to be really awkward and it's going to feel really weird. 0y plus 0x plus 0 equals 0, right? So we have 0 equals 0, which is a true statement. And if we think about it, if we think about the last time we dealt with stuff like this, that essentially meant that I had infinite solutions. So we have the same thing here. So let's put this into terms of a graph so we can actually graph this out and see what's going on. I'm going to put my line here and here because I have mainly positive numbers and it's a steep line. So if I look at this first equation, y equals 2x plus 1, I'm at 1. Let's put my tick marks on here. Sorry, you're going to have to deal with me taking up more time. 2x plus 1, I'm going up 2 over 1, up 2 to the right 1, down 2 to the left 1, down 2 to the left 1, and I can see a slope forming. If I look at this next one, this is not technically in slope-intercept form yet because the y is negative. So if I multiply all of this by negative 1, I get y is equal to 2x plus 1. And now I can truly see that's the exact same equation. Kind of cool, huh? So I have literally one line, y equals 2x plus 1, and this equation just right below it is the exact same equation. So if I were to graph it, again, I am just graphing right on top of what I already graphed. So we have the same line. Therefore, because they're the same lines, any point on this line, regardless if it's a point that's far towards like a negative infinity, going out in that direction, or if it's going far out towards positive infinity, or if it's like right here at our y-intercept of 0, 1. It doesn't matter. Every single one of those points is a solution for this line. Therefore, there is infinite solutions. So one more solution possibility. We had no solutions in the last video. This video, we have a situation where we have infinite solutions. So if you get a true statement of 0 equals 0, or you end up solving these two equations and finding they're the exact same equation, you can say I have infinite solutions. Awesome. One more video after this when we look at types of solutions we could potentially have for systems. And then after that, we do have one more video. I actually finalized my plans for this unit or this lesson. We do have one more video on categorizing systems. Thank you for watching, and I will see you in the next video. Bye.